Hey everyone, this is Maths Guy Channel here, and today we're going to be going through high degree polynomials. So building up the concepts we've learned for a linear factor, linear function, a quadratic, and a cubic, a high degree polynomial follows the same pattern with a power, and it's just to generalize it to x to the n, where n is just an integer, a positive integer in this case. So for example here we have the function f of x, and is here with the power 4 here. And we have this function, and what we do is like the usual, we substitute values in until we find intercepts. So after working out, you would get that f of 1 is 0, so therefore x minus 1 is a factor, and you use long division to get the cubic factor, and then you keep repeating the steps, and eventually you get all the factors you need. So in this case it is x minus 1, x minus 2, x minus 3, x plus 2, and as you can see, it works at x minus 2, 1, 2, and 3. That's what the function looks like. Okay, so now in the second case, we have this function here, f of x equals 2x to the 4 minus 5x squared minus 3. And you want to solve it for 0. If you go to this case, what you do is you create a substitution where you put u as x squared. So this whole thing becomes 2u squared minus 5u minus 3. And like a quadratic function, you find the two factors and you replace it. But in this case, we put replace it back. So this would be 2u plus 1 and u minus 3. We put the u back into x squared. And you realize here that 2x squared plus 1 can't equal to 0. So we ignore, we can't use that. But the x squared minus 3, we get two answers. X is plus or minus a square root of 3. Afterwards, you have there's four types of ways a quadratic function can be expressed. So the first one is if it has 4 distinct linear solutions, which just cuts the graph each time, so as like the first function here. The second one is when you have a repeated factor. So let's say for example, I have f of x equals x minus 2 squared, x minus 1, raise the power, x minus 1, and x minus 3. And here, you can see here, the cuts at x minus 2 here, it has the properties of the parabola where it just touches the graph, and whereas the other two factors only cut. So this pattern is the same thing, but with 2 repeated factors. So if I were to ditch this and go here, you might not be able to see it that well, but here you can see there are 2. The graph touches the x-axis twice. And the last one is 1 cubic factor. So if I were to go and change this to a 3, one. There. Not very good, but you can see here. X equals 1. The graph goes through the x-axis, but here it has this kind of saddle cut, which is expressed let's see, in the general form of a cubic, x cubed. So it has this sort of cut pattern here, and it has a similar pattern here. Alright, so if you generalize it to x to the n, you can go x to the 5th, and on its own, it's very similar to x to the 3rd. You can see that between 0 and 1, the value is less, but afterwards it increases. And same here in the negative direction. And if we use x to the 6th, x to the 4th, x squared, you can see that has a very similar pattern here. It has a sort of curved nature, and then everything else is just in a combination. So let's say for x to the 6th, I can write x minus 3 cubed, x minus 2 squared, x minus 1. Oh, that's a power. X minus 1. Okay, here. And you have all 3 characteristics. You have the cut here, the touch here of the 2, and the saddle cut of the 3. And yeah, if you need to find the factors of any high degree polynomial, you substitute to find one of the factors, and use long division to find find the cubic factor or whatever factor it is, and you repeat the step until you get all factors. Yep, that'll be all.